Good morning, students. Today we are going to perform the first experiment from paper 1. Paper 1, you know it, it is PS EVS 301, and here in case of the paper 1 we can find out there is two major subheading, that is minor experiment as well as a major experiment. So today we are going to perform one of the minor experiment, that is first one, that is determination of heavy metal, that is iron, by spectrophotometric methods. So today we are going to discuss how to find out the heavy metals just like iron by means of spectrophotometric method in the laboratory. Today I have already posted a link regarding how to perform the estimation of the iron by means of spectrophotometric method, and today we are just going to discuss it how to perform in the laboratory. So for the experiment, that is determination of heavy metals like iron by spectrophotometric method, we need or we require certain chemicals. A name of the chemical, the first one is the hydroxyl amine hydrochloride solution. Next is the phenolphthalein, PHENO phenanthroline. Next chemical, ammonium acetate, we use this chemical as a buffer. Next we need a stock solution of the iron, that is 200 ml per liter, yeah, you can say that 200 ppm of the iron stock solution we have to prepare, and from this 200 ml per liter or ppm we have to prepare the 10 ppm stock solution of the iron. So the requirement for this experiment, we need first one, that is hydroxyamine hydrochloride solution. Next is the phenanthroline, and third one is the acetate buffer, and fourth one is the stock solution of the iron. From this stock solution we have to prepare the working solution, that will be the 10 milligrams per liter. And these are regarding the chemical, and regarding the instrument which is required is nothing but the prepared standard volumetric flask, etc., tubes, etc., for the preparation of these chemicals. Next, so our main aim of the experiment is to determine the iron by spectrophotometric method. So what is the main theory behind this experiment is that presence of iron in public water supply occurs in both soluble and the insoluble form. ये जो iron होता है, it is present in the water, both soluble and insoluble दोनों form में available होता है. So when iron is present in considerable amount in water, it imparts color. So if you can say that if the iron is present in the water in a particular range, then it is okay. If it exceeds is beyond its limit, then it imparts a color. So it imparts color development and objectivable test even at the low concentration. So if the iron is present in the water, given water sample in low concentration, then also it can be estimated. Next is that it also develops turbidity when exposed to the air. So if you keep the water which is containing high amount of the iron for 1 hour, then you can find out that when it is exposed to the air, it becomes turbid. and due to its conversion to Fe3 plus to the another state, that is Fe2 plus state. So here you can see that the water presence of the iron makes the water turbid, and hence the water becomes not potable for the drinking purpose and also for the aesthetic point of view. So the water what we are consuming, or it should be potable, and the iron content of the water should always be in the permissible limit. So today, by doing this experiment, we are going to find out what is the percentage of, or what is the content of the iron in the water sample, and why this given water sample is objectionable, or you can say why we used to reject the sample, or we are going to find out whether the given water sample is potable or not for the drinking. So here we have seen the theory behind the experiment. So this is the theory. Next, coming up to the principle. So the principle is that here iron Fe2 plus, when reacts with the phenanthrolene, it forms a blood red type of color, or you can say red color. That is nothing but the iron phenanthrolene. And this Fe2 plus in iron is reduced to the ferrous form by means of the hydroxylamine hydrochloride solution and the phenanthrolene at pH 3.2. So this Fe2 plus in the presence of the reducing agent, that is hydroxylamine hydrochloride solution, reacts with the phenanthrolene, that is pH 3.2, and it forms a soluble chelate compound, that is orange red color with the ferrous. And you know that the color is proportional to the concentration of the iron. So as the concentration of the iron increases, the intensity of the color also increases. So you can say that the more intense iron, if the concentration of iron is more, then the color will be more, or the intensity of the iron will be the more. So this was regarding the principle. Now coming up to the interpretation, how to interpret your result. Before interpretation, we must know the working. So how to what is the procedure for estimating the iron content in the water sample. So here we have to perform the three procedure. First one with the sample. So this is the sample. So we have to perform the three procedure, one for the sample, another for the standards, and third is the preparation of the blank. So what to do with the sample? We have to take 50 ml of the sample. It should be always remember that the sample should not contain more than 200 ppm of the iron. So it should be less than 200 ppm. Therefore we have to dilute it, and then we have to take the volume should be 50 ml. So sample should be taken 50 ml. In that sample we have to add 2 ml of the concentrated HCl and 1 ml of the hydroxylamine solution, and to that we have to add the 10 ml of the acetate buffer, and after that we have to heat it up till the content becomes half, that is kitna reh jayega, if it is 50 ml it is left with only 15 to 20 ml. So it should be left till 15 to 20 ml. So you can say that when the content is half, till that time we have to heat it up, then we have to cool it. इसके बाद इसको क्या करना है, हमें cool कर लेना है. So we have to heat all this content and then we have to cool it, and after cooling what we have to do is that we have to add, so to cool it, and then we have to wait for 10 to 50, make the volume up to the 50 ml, 50 ml के mark तक उसको करना है with the water or distilled water. And then we have to what we have to do is that we have to wait for 10 to 15 minutes for the color development. Color development के लिए wait करना है, and after 10 to 15 minutes we have to take the OD, means optical density, at 510 nm. So this was the procedure regarding the sample. What we have to do with the sample. Now how to prepare the standard. So similarly we have to prepare the standard series. For the standard series, a particular working solution is already given to you. The working solution, that is 10 ppm solution, is given to you, and from this 10 ppm you have to take almost 0.5, we have to prepare 0.5, 1.0 ppm, 1.5 ppm and 2 ppm. So these are regarding the standards, and then we have to make a particular volume, that is 50 ml, and by means of adding the 1 ml of the HCl we have to do the same what we did with the sample. So instead of here water samples, we have taken the standard sample. So here we can find out there are 5 volumetric flask with different grades of the ion concentration. So this is 0.5, this is 1.0, 1.5 and 2. So here also we have to add the same thing, that is 2 ml of HCl, 1 ml of hydroxylamine and 10 ml of acetate buffer, and then we have to wait for 10 to 15 minutes, and then we have to take the reading at 510 nm. So in case of the blank, what we have to do is that here we are adding the concentration of ions, but here we have to add only the water, distilled water. So here we are not adding any type of the standards which is given, but we are adding again 2 ml of HCl, 1 ml of hydroxylamine and 10 ml of the acetate buffer, and rest will be the distilled water. So we have to make it to the 50 ml, and then we have to take the OD at, we have to take the OD by means of adjusting the 0, and after adjusting the 0 we have to take the readings of the standards, and after this we used to get certain values for the standards, that is 0.5 we will get certain values, for 1.0 will get certain values, for 0.5 will get certain values, and 2.0 will get certain values. So we have to plot a graph against the OD. So OD will be in the y-axis and the concentration will be on the x-axis. So we have to find out the points of the sample. हमें sample की reading इस standards में कहाँ मिली है, will come to know, and as soon as you'll get the concentration we have to calculate for the amount of ion present in the solution, your water sample. So next, you know the procedure. The procedure, we have to deal with the 3 type of samples, that is water sample. Next will be the standard procedure for the standards preparation series, and next for the blank. So the procedure is 50 ml of the sample we have to take. We have to add 2 ml of HCl and then 1 ml of hydroxylamine. Then we have to heat it till till its concentration reduced to half, and then we have to cool it, and then we have to make the volume to the 50 ml with the distilled water, and then we have to add 10 ml of acetate buffer as well as the phenolphthalein as an indicator, and then after 10 to 15 minutes we have to take the OD at 510 nm. So this is regarding the procedure of the ion concentration. Next, what do we interpret? So after the calculation, so what is the calculation? Normally the calculation is concentration of the given sample is equal to concentration by graph into dilution factor. So what will be the dilution factor? We have to multiply with the dilution factor. So if from the graph, consider if you will get the reading as 1.5 into 100 divided by 50. So 50 ml of sample, it was diluted twice. That's why we have written 100 by 50. So 1.5 into 2 will give you the 2.8 ppm. So the concentration of the ion is 2.8 ppm. So how do we infer that the given sample ion concentration is in the permissible limit or not? So for that we must know what is the permissible limit by means of WHO or by means of BIS, Bureau of Indian Standards. So what do we interpret from this experiment is that the surface water contained less than 1 milligram per liter of the ion. So surface water में कभी भी ज़्यादा कितना 1 milligram per liter of the ion present रहता है, and that may be soluble or insoluble form. And high amount of ion causes staining. अगर पानी में ज़्यादा amount of ion होगा तो उसके कारण क्या हो जाएगा, कपड़े में स्टेन या फिर धब्बा बोल सकते हैं, या फिर पूरा वाइट नहीं होगा, एंड एक different odor used to, or bitter, it gives a bitter taste to the food. And according to the WHO, permissible limit of the ion is 0.3 milligrams per liter. So in case of examination, you will be asked what is the concentration of the ions. So you must know the concentration of the ions or the permissible limit of the ions. So what is expected? It is expected that it should not be beyond 0.3 milligrams per liter. So what is the calculated value what we got? That is 2.8 ppm. So we know that 2.8 ppm is beyond the permissible limits. So we can say that our sample contains ion in more than the permissible limit. So the examiner, sometimes they will ask you how you are going to remove the ion from the water. So the removal of the ion can be accomplished by using the aeration. हम aeration देके या फिर by means of sedimentation or by means of ozone treatment, ion exchange, lime softening. These are the different process which when applied to the water which is containing more amount of ion can be reduced. So from this experiment, what we can conclude is that what you can interpret is that the given sample contain, you know that our sample was containing 2.8 ppm. So the sample contain more amount of ion as compared to the WHO standards. So you must know the permissible limit of the WHO standards or the BIS standards. So whether the limit falls inside the given permissible limit or not, we have to find out by means of this experiment. So today we have completed the determination of ion by spectrophotometric method. So by this we are going to find out the amount of ion present in the given water sample. So see you tomorrow with the next experiment. Thank you for listening.